Now in this lecture we'll see basic concepts of thermodynamics. What is thermodynamics? Laws of thermodynamics, thermodynamic system, thermodynamic properties like pressure, volume, temperature. What is the difference between point function and path function, and different forms of work transfer or different types of work transfer. So let us start with the definition of the thermodynamics. Now, thermodynamics is nothing but what? It is the branch of science which deals with the energy transfer and its effect on the state or condition of the system. For example, if you consider the case of internal combustion engine, then the chemical energy of the burning or combustion of the fuel like petrol or diesel will be converted into heat energy, and that heat energy is used for the reciprocating motion of the piston inside the cylinder. And due to the reciprocating motion of the piston, that energy, that reciprocating motion is converted into rotary motion of the crank with the help of connecting rod, and with the help of differential that motion is transferred to the wheels and will get the motion of the vehicle. So energy is transferred from the heat energy into the mechanical work. Similarly, in case of reciprocating air compressor, to drive the compressor we'll use the electric motor. So electrical energy is used as an input, and then suction valve, it takes the atmospheric air inside the engine inside the compressor cylinder. It compresses that particular air, and then it is stored in the receiver, and then it can be used for the various purposes like for filling the air in the tire tube, then for pneumatic activation or pneumatic cylinder, then you can have the pneumatic hammer, then air motors, etc. So here also the energy transfer, electrical energy is transferred into the motion of the piston inside the cylinder with the help of again single slider crank mechanism. Similarly, if you use the steam turbine power plant, in that particular steam turbine power plant, high pressure, high temperature steam superheated steam is allowed to expand on the turbine blades, and the turbine rotor starts rotating, and that particular motion is converted into, that mechanical energy is converted into electrical energy when that shaft is coupled to the generator. So this is the way of energy transfer. This entire branch is known as the thermodynamics. Now we'll see the laws of thermodynamics. Zeroth law, it says that it is associated with the thermal equilibrium of the bodies and equality of the temperature. It says that if A is in thermal equilibrium with body B and body B is in thermal equilibrium with body C, then A and C can be said to be in equilibrium, thermal equilibrium with each other. So A, B and C, they are together simultaneously, they are in thermal equilibrium with each other. First law of thermodynamics says that it is the law of conservation of energy. So energy can be transferred. Energy can neither be created nor destroyed, but can be transferred from one form to another form. Now thermodynamically, we can say that Q is equal to delta E plus del plus W, or delta U plus W. It means that when you supply the heat, the work transfer will take place, and energy will be, some part of the energy will be stored within the system, and that is known as the internal energy of the system or stored energy of the system. Then second law of thermodynamics, it is related with the direction of heat flow. So here it just says that heat can be converted to work, but here it will say how much amount of the heat can be converted into work. So it introduces a property known as entropy. So entropy is a separate chapter, and it introduces the principle of increase in the entropy. So entropy of the universe always increases. That is the meaning of this particular sentence. So we'll derive the expression for this also. Then third law of thermodynamics, it forms the basic basis for the calculation of the absolute entropies of the system. So entropy means disorder within the system. So what is that disorder that can be calculated with the help of the third law of thermodynamics, or entropy can be used as a basis for calculation of the heat and work transfer and the irreversibilities and disorder within the system. Now, there are two approaches which you can use for accessing or for evaluating the behavior of the thermodynamic system. One is microscopic approach. So in this particular case, we have to consider what will happen to the energies at the molecular level. Whereas in case of the macroscopic approach, the bunch of the molecules it is taken under consideration for the analysis of the system. Then thermodynamic system, the most important part. Now it is the region in space on which the attention is made from the energy transfer point of view. For example, IC engine is the most important part. If you remove the engine from the car, there is no use of that particular car. So energy transfer take place within the IC engine cylinder. So that is the region on which the focus is made from the energy transfer point of view. So that is known as the thermodynamic system. Anything that is external to the system is known as the surrounding. For example, steering wheel, wheels, bonnet, all the other parts, they are surroundings. Now there is a boundary that is known as the thermal boundary, which will separate this system and surrounding. And system and surrounding together, they will form the entire universe, that is thermodynamic universe. Now types of thermodynamic system. So closed system, open system, and isolated system. There are three types. So in case of the closed system, there is no mass transfer take place, only energy transfer will take place. So for example, bomb calorimeter, pressure cooker, gas confined in piston cylinder arrangement, and there is no intake of the mass and outgoing of the mass, only gas confined in a piston cylinder arrangement that we are considering. All these systems we will see in detail afterwards. In case of the open system, there is a mass transfer as well as energy transfer. For example, in case of the steam turbine, steam enters from one side, high pressure, high temperature superheated steam, and then after doing the work on the blades, turbine blades, it will leave the system. So mass transfer is taking place simultaneously. The heat energy of the steam is converted into the mechanical energy, and then further that particular mechanical energy will be converted into electrical energy with the help of the generator. Similarly, for the reaction turbine also, for reciprocating air compressor also, you take air inside through the suction valve, that air is compressed and then compressed air is stored in the receiver. Now the motion of the piston and cylinder motion of the piston inside the cylinder is achieved by the motor, which is electric motor, which is attached to it. So energy transfer is taking place as well as the mass transfer is also taking place. Similarly, for the centrifugal compressor, axial flow air compressor, etc. Now, in case of isolated system, there is no transfer of mass and energy. For example, the thermos flask. So you are pouring the hot tea inside it, it will remain as it is. No mass transfer will take place, no energy transfer will take place because insulation is provided to the system.